Okay, this is the P2 paper from June 2021. It's question number 6, and as we can see by looking at it, this is a coordinate geometry question actually to do with equations of circles and triangles in circles. But let's make a start and we'll see what's going on with it. So it says a circle has the equation x squared minus 6x plus y squared minus 8y plus k is equal to 0. We're going to have to try and find k, and it says given that the x-axis is a tangent to this circle. So let's draw a quick sketch out and just see how that's going to have any impact on what I'm going to try and do. So if I draw a set of axes, perhaps slightly better than that would be good. Draw a set of axes out. So if the x-axis is the tangent, then the circle basically needs to look something like that, where it's just touching there. Now, it doesn't have to be there. It could be there. It could even be here or here. We don't know where it's going to be, but certainly we know it's just going to be touching there. So what that means is, if I can work out the center, if I work out the center, then I'll be able to work out what the radius is going to be if I know the y value of the center, and then that's going to get me going with the question. So I'll come back and draw the diagram out again later for what I need, but at the moment, at least I understand that from this, what I've really got to do from this circle is to work out the center. So that's a fairly standard thing. X squared minus 6x plus y squared plus 8y plus k equals 0. They could have just asked me to do that for part A. They could have said, can you find the center of the circle? And then moved on to the rest of it. How do I find the center of the circle then? Well, for a circle, what I want is it to look like this. X minus a squared plus y minus b squared is equal to r squared, because then AB will be the center and r will be the radius. So what that means in terms of what we've got here is what I need to do is to complete the square on that part, complete the square on that part, so I can work out my A and I can work out my B. Right, that's how we do it. Let's actually go ahead and get on with doing all that. Give me a second just to tidy all this up. So if I'm doing this then, I've got x squared minus 6x. Now if you've got your own method for completing the square and you understand it, just do it and complete the square on it. I always just explain the way that I do it. Is what I do, is I look at that number there, I half it, which gives me 3, and I say, okay, plus 3 squared minus 3 squared. That's made no difference to my terms, and yet what that now means is that this bit here later on will be a perfect square. Let's do the same thing for the y's. So I've got y squared plus 8y, so I half 8, which is 4, so it's plus 4 squared minus 4 squared plus k equals 0. Now, as I said, that bit there is a perfect square, so that's x minus 3 squared. That bit there is a perfect square, that's y plus 4 squared. The minus there means I get a minus there, and the plus there means that I get a plus in there. So now I've got to work out what's happening with the other numbers. I've got minus 3 squared minus 4 squared plus k equals 0. So in other words, I've got the x minus 3 squared y plus 4 squared is equal to, take everything over to the side, 25 minus k. So what I know from that now is I know the center of the circle. The center of the circle then is 3 minus 4. So if it's 3 minus 4, what I'm going to do now, I want to work out k in a minute, but I'm just going to quickly sketch out what that's going to look like now, and sketch it relatively accurately in the fact that, okay, let's just get this drawn in. If I draw my circle then, I know that my circle is going to have the x-axis. Let's just do it. I know that, sorry, let's just say that again. My circle has got the x-axis being a tangent, so that means it's just about touching there. Because I know that this value is minus 4 here, that means that the radius is going to be equal to 4. But if this value here is 3, because it's 3 minus 4, then I know the circle must come through into the quadrant on that side there. Okay, so when I'm doing that, just took a little bit of time to make sure I'd got that in the right place. And now I'll actually put everything on that I need to have on here. So I know that that centre there is the 0.3 minus 4, which means that's the 0.3 there. I'm not going to put this on at the moment, but if I had that point there, that would be the point minus 4 on there. Right, so we found where the centre is, which means that I know that that length here is equal to 4. But if that length here is equal to 4, then the circle can also be written as x minus 3 squared plus y plus 4 squared equals 4 squared, because it's equal to r squared, or equal to 16. So these two have to be equal to each other. So if that's true, 25 minus k is equal to 4 squared. So 25 minus k is equal to 16. So k works out to be equal to 9. So I've managed to do part A, which was see if we could find k. Part B then says the circle meets the axes at the points R, S, and T. Yeah, well, I already knew that as we were actually going through and doing it. They said which one's which. I'm going to say this is R, this is S, and I'm going to say that value there is T. So we've got R, S, and T here, and then it says, can you calculate the area, the exact area of the triangle RST? Let's draw that in a different colour so we can just talk about what we're doing. What we're saying then is, can I find the area of that triangle? Can I find that area in there? So this is a really nice, clever question that they do quite often, or this idea coming through of, if I want to work out the area of a triangle, what I want to do is half base times height. So if I'm going to do that, what I can say first of all is that the height of this triangle here is going to be equal to 3. So what I need to do is to work out the base, which is RS. Now I'm going to take all that off because I'll say that when I'm actually going ahead and doing it. But again, it gives me an idea now of what I've got to try and do. I need to work out the length of RS, and the way to work out the length of RS is to work out R and work out S. If I can work out those two, then I've got it. So if I want to find R and S, so to find R and S, what do we know about R and S? That at that point, we know that X is equal to 0. If it's on this axis here, then the one thing I know about this point and this point is that they both occur when X is equal to 0. So I can put that into my equation for the circle. So let's make that clear to the examiner now. To find R and S, X will be equal to 0. So let's write out the equation. X minus 3 squared plus y plus 4 squared is equal to 16. That's the equation I've got now, and we're going to say X is equal to 0. So if X is equal to 0, I'm going to get minus 3 squared, I'm going to get 9 plus, and then multiply out the bracket y plus 4 squared. If you need to take a little bit of time to do that, then you can do. It's y squared plus 8y plus 16 is equal to 16. So what we've now got to do is to go ahead and solve this quadratic. The 16s are going to cancel there. I'm going to get y squared plus 8y plus 9 equals 0. When I was doing this earlier, I got a bit excited and thought it just factorised, but it doesn't. It's not it's not 9y plus 8. That would factorise, but this way around it doesn't factorise. So you've got to use a quadratic formula on it. So y works out to be minus b plus or minus the square root of b squared minus 4ac all over 2a. Chuck everything in. We're going to get minus 8 plus or minus the square root of b squared, so 8 squared minus 4 lots of 9 all over 2. That works out to be minus 8 plus or minus 2 root 7 over 2. Tidy that up. Obviously we can divide by 2. It works out to be minus 4 plus or minus root 7. Now this is good use of surds here, that what I've actually got then is that, going back to my diagram, I've got one of these values is -4 plus √7. The other value is -4 minus √7. And if I want to work out the distance RS, it's going to be one of them minus the other one. So we actually get then RS works out to be, what are we going to say? Which one first? Well, it depends on whether you want it as a positive or negative, doesn't it, in terms of the length here. So I'm going to say -4 minus √7 minus 4 plus √7. That's going to work out to be -2 √7, but I'm not bothered about the minus, it's just 2 √7. So the length of that is 2 √7. So if the length of that is 2 √7, coming back up here in my triangle, in fact, I'm actually just going to draw this out just to make it clear to the examiner what I'm doing. What I've now got is I've got this triangle where I know that this is 2 √7, and I know that that length there is 3. Okay, it's 3 because of the fact that we've got that value in there. Okay, so if I've got that area, I don't think you need all this, to be honest. There's more explaining it to you than actually writing it down. Area is equal to half base times height, so it's half 2 √7 multiplied by 3, and that all works out to be 3 √7. Just a quick couple of notes about that then. First of all, it said find the exact area, so I knew I was going to be working with something similar to that. And then this idea about working out the area of one of these triangles, quite often you are using coordinates to maybe work out lengths. So just be aware of that. That's a relatively standard sort of idea that they have. The diagram helps massively, obviously. If you hadn't drawn the diagram out and didn't draw it out relatively accurately there, you'd be all over the place. So hopefully a couple of learning points from that. Hope that makes sense.